Okay, I'm going to do a quick walkthrough of these Showa 49mm conventional forks. I think they were on 1996 to 1998 RM125 and RM250s. They externally look very similar to the forks on a DRZ 400, but internally they're quite different. These are closed chamber forks. The DRZ forks are open chamber forks. So what that means is you have lubricating oil in the outer chamber that just basically sets your air chamber height. So when you're measuring your volume that you put into the fork, that is one of your volumes, and it lubricates seals and bushings. And the other cartridge, the inner cartridge, is actually pressurized as it's operating. It's pressurized actually by the spring right here. And it's closed off separately from the outer chamber, where in an open chamber fork, all of that oil is free to move between chambers. The benefit of the closed chamber system is it resists cavitation much better. And you can also, to some extent, if you have like a leaky fork seal or something, it takes a little bit more of a leak before you actually start impacting your fork performance. However, you should never actually get to the point where that matters, because you should keep your fork seals working well. But that is one side of it. So I do have a fully assembled fork over here. If you notice that these look, this one looks a little shorter than you'd expect. It's because they've been shortened about 4.5 inches for a non-RM application. So that's what they look like. Big old lug on the bottom. They're 49mm diameter. These forks that I'm taking apart here, I mean, of course, always have a clean workspace, especially with delicate things like forks. These are being taken apart and basically cataloged and partially thrown away. In this case, the chrome is bubbling on the fork tube, and the fork slider actually has a big old dent in it. So about halfway through its travel, this one binds up. Is it this one? Actually, it's I don't remember which one it is now. One of these binds up. It's got took a hit to the outside and is actually deformed enough that the slider is no longer round. So I've got one of these apart here. Well, we'll talk through what the guts look like, and then I'll film a little bit of how to actually take it apart. I haven't really seen much on the internet about these. They're kind of pre-internet forks, right? So you don't have the wealth of knowledge that you would have on some of the new like WP stuff, air forks and whatnot, where everybody does a video on them, and everybody has teardown instructions. So it took me a while to figure out how to take these apart. I'm sure there's instructions somewhere, but after 20 minutes of looking, I got fed up and figured I'd just do it myself. So, well, first we'll go through the guts of it, and then I'll take one apart and see if I can actually do a halfway decent job of filming it without showing the mess that is the rest of my garage. What we have here is all the pieces of the fork, your lower slider, the fork leg itself, which has some wear on it from the brake lines and just generally being well used. You have the upper fork tube. So at this end it gets clamped in your triple clamps. At this end you would have your lower fork bushing. This guy would be on there to support the lower end of the fork, and then you have your refill holes that allow oil to get between the fork seal up here and the bushing. So the fork seal would be stationary as this is moving in and out. You have to equalize the volume in there to make sure it doesn't build pressure or go into a vacuum. And that's what these holes do. So nothing else special here. It's basically otherwise just a big pipe. The fork seals in this thing are just like almost every other conventional fork out there. You have so in this you have a recess where your upper fork bushing sits, which actually goes in there. It pushes in. I don't really want to do that, I guess, because I won't be able to get it back out again. And then you have your actual fork seal. This guy, this is the backup ring. So this goes in that next most groove. This is what actually seals the oil in. Then you have your snap ring above that. And then the thing that you can see from the outside is the dust scraper seal. All of those on this one are fairly new, but they were all leaking because of the damage to the chrome on these. So that's the outer stuff. That's what you can see. Normally when you take these forks apart, you can see the bottom of this is it's totally open right now. There is a snap ring in there that separates the lowermost outer bits from the innermost bits. And what those bits are so this piece sits in there. It would slide all the way up the fork body and sit against that snap ring. You can see it has a groove in it. And then on the other side of that, and this would be visible from the outside, is this outer, this has your seal in it, and it's not even thread in. Like it's got notches in it like it would be. These just push in there the seal. So that's normally what you'd see from the outside along with your rebound adjuster. That sits in the middle of this. Again, it's got an O-ring seal on it as well as having a copper crush washer. So let's get this guy back out of here. So if I were to assemble the inside of this outside the fork, this hex interfaces with the female side of the hex here. This groove is now the width of that snap ring. So this forms the bottom part of your fork retainer. The threads right here thread into this guy. So this is what keeps the fork from basically blowing apart. So this would thread in, it would clamp these two sections fully together, and this is why you can loosen this without actually spinning the inside guts, is because they have that hex interface. So this keeps it all together and keeps it all in the fork. On the other end of this, or on the inside of this rather, you can see there's this D-shaped cross-section shaft, which is, there's no valve in this. This just actuates, this is just the part that clicks. There's also threads in there. So you would have, this would be sticking up inside this hole, and you would have that going into your damping rod, which is this guy. And you can see there is a little D-shaped tube in there, which I might actually be able to get out using that. So this whole thing turns. When you turn your clicker, what you're really doing is you're turning this shaft that goes through this rod, and then there's another matching D cross-section shaft in here. Your clicker is actually housed in this, it'd be the rebound tap, I guess they would call it. So that little hole right there allows your bleed. So this hole right here is connected to that hole internally. And what you're doing is you're threading a needle in and out of a seat that limits the flow through this orifice. So that's what you're doing with your clicker. And this is the rebound clicker, but the fluid actually flows in both directions. It's a little bit of a misnomer. It has more of an effect on rebound, but it does also affect your compression at the same time. So stiffer rebound does also mean slightly stiffer mid-speed compression. This, like I said, is your the actual damping rod. The cartridge is this piece right here. So normally this would be inside this cartridge, right? And you would have this cap screwed on the top. So this cartridge with this piston sliding inside the bore and with a seal and a bushing at the bottom, that keeps the oil that is inside the cartridge. It does have a built-in overflow if you were to, when you rebuild these, if you put too much oil in them, You don't want it to be able to hydrolock, right? When your suspension compresses, as the piston moves up in the cartridge, you're displacing the oil that is the volume of the damping rod itself. And that oil is what goes through your base valve, which on a twin chamber conventional fork like this is on the top, your compression adjuster accessible from the top. This is the compression piston. These typically, and this is no exception, are they have a free valve on the rebound side, so these do nothing on rebound. It just lets fluid flow back. On compression, the only fluid that's flowing through this when it's working right is the fluid that's displaced by this rod. So as this enters the cartridge, it's displacing fluid. It has to go somewhere so it doesn't hydraulically lock the fork. It's going to go through this shim stack, and it's going to go into this compensation chamber in the back. So you have a seal and a bushing in your compensation chamber, which rides in this section. This threads into here. So you can see where the piston would sit in the smaller diameter, and then your ICS would sit in this upper part. So as fluid flows through this, it's compensated for by compressing this very stiff spring. And what that does is it maintains pressure on the oil inside the cartridge, and that prevents it from getting into a situation where it could cavitate, meaning it pulls entrained air out of the fluid. You never want it to go into a vacuum because it'll get all foamy, and you will suddenly lose all your damping, which gets very unpredictable, to say the least. So that's kind of how it works. You can see again the clicker here. There's a rod that goes through from your clicker. This is your air bleed screw. This just runs a rod here that has a valve again in your compression tap. That hole's where the fluid would be able to get to the cartridge itself, and this is the bleed hole out. So it just again meters an orifice in there and allows free flow past this piston. Relative to other forks, especially modern forks, the geometry of this is a little bit strange. It's a very, very, very small diameter cartridge, very, very small diameter piston, both on the rebound and the compression, the base valve. Not such a big deal maybe here, but I bet you hit probably some flow limitations with as small as the holes in that piston are. At some point you can only get so much fluid through it. However, it is also a smaller rod. This is a 10 millimeter damping rod, where most forks today typically use a 12 millimeter for a while. Some of the upside down forks are using like a 14 millimeter. So that's a tuning tool you can alter how much fluid flows through the base valve piston. A bigger rod will give you more fluid flow through your base valve, make it do more work. So that is how the guts of this thing all work. I know maybe it's not as clear as it could be. The spring is sitting on the floor in a bucket because it's covered in oil. This would be the spring. It's really a spacer. I think people call it a spring guide. You can see all these pieces that sit at the bottom of your fork. This would sit inside that, and it's a fairly tight fit. So all of this is in the bottom of the fork, and these holes allow fluid to move freely. And this piece, so you can see the threads on this, you have to take this nut off to get the whole thing apart, to get it actually out of your cartridge assembly. So if you were to thread this back in, and I'm doing this upside down, if you were to thread this back in this way, this is how it would look when it comes out. And this threads into your rebound valve, which I have set somewhere. So this would thread into the rebound side, and I don't know what I did with that. It's amazing. There's not that much on this table, and I still managed to lose something. So this would sit down inside here, and it would thread into your rebound nut assembly on those inner diameter threads. And then your cartridge would come down and be hanging out around here. Spring sits up here. This is an upper spring spacer that I don't think all these forks had. It actually slides up this way and covers up the top of this, so your actual spring space is from about here to where this washer is up here, and this sits up against the face of this when it's all put together. Oh, right here. When you do put these back in, you want to make sure that you have engaged the adjuster. You'll feel it kind of go into its home, just like so. When you do thread this in and out, it'll do a lot of clicking. That's totally normal. This can rotate infinitely. It's only the valve at this end that can't. So when this is all threaded into the bottom of the fork, and then, well, no, it actually does fit. Okay. So, of course, now that I've made sure it fits, it's upside down. So this would be at the bottom of your fork. This threads into this piece here, and this is how your whole cartridge gets assembled on the inside, and so when you take all this apart, the spring is actually not retained by this. It is self-contained between the big old nut that's on top of this that holds the compensating spring and the base valve, and on the other end it's retained by basically these threads right here. So it can't really go anywhere as long as this stuff's tight, but if it comes loose, that's where you see those YouTube internet things of people losing the bottom of their forks.